Dear students, in today's video we will learn about parallelogram law of vector addition. So when you have two vectors acting from the same place or same point in two different directions, we use parallelogram law to find out its resultant. What do I mean by that? Let's take an example. Let's say you all know probably about Messi, right? He's a famous footballer. Let's say Messi wants to kick a football in this direction. Another footballer, Ronaldo, wants to kick the football in this direction. So Messi wants to kick in the direction in this direction, and Ronaldo wants to kick in this direction. And if they kick the football at the same time, at the same instant, in that case, the ball will not go in this direction or that direction, it will go in this direction. This is the resultant. This is the idea of resultant. If two vectors act towards this and that side at the same time, then the resultant will be always towards the diagonal of the parallelogram that is being drawn. Let's say I give you another example, or let's say I try to understand you the mathematics behind it. So I have a let's say I have a vector, let's say A. So let's take this vector to be A, and I have another vector, let's say that is B, and both of them are acting at the same point, from the same point. They are acting from the same point. Let's say that point is, let's say this is O. Okay. So if A vector and B vector act at the same time, then my resultant would be towards, let me draw a parallelogram using these two lines. So I draw a parallelogram, and then I draw the let me change the color. Okay, then I draw the resultant, which is along the diagonal. Okay, so this is my resultant, and this resultant, let's call it R. It's along the diagonal. So what parallelogram law really says is that vector R is equal to vector A plus vector B. This is what it essentially says, right? Now how about we find out the value of R? Value or magnitude of R. Magnitude of R meaning magnitude of resultant, right, which is R. How do we find it? First of all, let's take this angle to be alpha. So alpha is the angle between vector A and vector B. This is the angle between vector A and B. Remember, this is the angle sign. This sign here is the angle sign. And let's say I have another angle with A and vector R, that is theta. So this angle, let's say I have another angle. This angle is taken to be theta. I choose the angle arbitrarily. Okay, this is my choice. You can choose it differently. So in order to find out the value of R, let me draw a let's say a right angle triangle. Okay, so I draw a right angle triangle here. So this is 90 degree. So if this vector is B, then we can say this vector is also B. This is also B. Okay, so why don't I use a different color? This will confuse us, right? Let me use this color. So this is also B. Okay, this is also B. You know why? Because vector can be translated. So if you take this vector and then you don't change its direction, you can literally translate it to here and it will not affect that vector. So vector can be translated. I can take this vector anywhere. I can vector it in, take it in here, but I don't I must not change its direction and its length. Okay, so if you don't change the length and the direction, you can translate the vector. Okay, that doesn't affect the result. So now I have another vector which is b. I have this vector to be a, this is to be b. So we already know that the angle between vector a and vector b is alpha, right? So from here we can say that the angle between vector a and vector b is alpha. So this angle will be alpha. So okay, I'm done. Now let me erase this. You know why? Because you most probably know this is 90 degree. I don't have to keep it written. So now as this angle is alpha, this angle is alpha, you know that this component right here will be, it will be b cos alpha, right? This is b cos alpha. In our earlier video we have explained why this is b cos alpha. Remember always, if angle is inclined with a direction, that direction becomes cosine. Okay, always remember that. And if angle is not inclined with other side, other direction, that becomes sine of alpha. Hence this is b sine alpha. So now let's use Pythagorean theorem. It's very easy. So according to the Pythagorean theorem, I have this r square, which is basically my hypotenuse. So I can write r square is equal to, okay, let me erase that. I can write r square equal to a plus b cos theta. This is a, this length is a, and this is b cos theta. So I have a plus b cos theta. So I have a plus b cos theta, which is basically the adjacent, right? This is the adjacent and this is the opposite. This is the opposite. So opposite is b sine alpha whole square. So this is the Pythagorean theorem. According to the Pythagorean theorem, I have hypotenuse square is equal to the adjacent square plus opposite square. Okay. Now see, listen, I found the resultant using the vectorial form. Now I want to find the magnitude. That's what I'm doing, right? So now I have this thing right here. I can use the formula from your elementary algebra course. That is, this is a square plus 2ab plus b square. You probably know that, right? I mean, you must know that. Okay, so I have a square plus 2 times a times b into cosine of alpha plus cosine square alpha. And here I have b square sine square alpha. Now I have a square plus 2ab cosine of alpha, and then, okay, sorry, I made a mistake. I made a silly mistake. That is I have this b, so I should have written b square cosine of alpha square. So I have a square plus 2ab cosine of alpha, and then I can take b square as common from these two terms. So I can take b square, and then I have cos square alpha, and then I have sin square alpha plus sin square alpha. And you know from your geometry course that cosine square alpha and sin square alpha is basically 1. So cosine square alpha plus sin square alpha is equal to 1. So hence I get a square plus b square plus 2ab cosine of alpha, that is r square. Now if I want to find out r, I would take the square root, right? So this is how I found the resultant so far. So let's take, okay, so let's take the square root of this. So I have r, which is basically equal to square root of a square plus b square, a square plus b square plus 2ab cosine of alpha. You must remember this equation. So I have put it inside a box so that you understand this is very important formula. Now let's try to figure out the direction of, so what we did earlier is that we found the value of the resultant. Now let's try to figure out the angle that our resultant makes with the vector A. Okay, so let's find out theta. Theta is the angle that our resultant makes with vector A. So let me write down the direction of resultant. So let us find out the direction of resultant A, resultant R, not A, resultant R. So the direction of resultant, our resultant R makes an angle theta with vector A, So let's find out that theta. So let's find out theta, because theta is the direction of resultant R. So you might ask, sir, why didn't you, teacher, why didn't you find out the resultant or the direction of the resultant with the vector, let's say B? Because I found it against A, I could have found it against B also. I could have considered it beta and then I could have found out beta, right? That doesn't matter. We have to find out, at least we have to find out against A or B. So I choose A. So for the purpose, I have to read out this figure. I won't do that because I'm just going to copy it. Okay, I'm just going to copy it. Okay, now we know tangent equal to opposite divided by adjacent, right? Adjacent, or some say opposite, some say perpendicular divided by base, okay, which is also correct. So with respect to theta, my opposite is b sine alpha. Opposite is simply b sine alpha, and my adjacent is this side right here, which is a plus b cos alpha. The whole length is a plus b cos alpha, right? So this is a plus b cos alpha. A plus b cos alpha. So that's it. That's the direction that you have to find out. Now theta is basically the arctan or tan inverse b sine alpha divided by a plus b cos alpha. If you want to find out the same formula against, let's say, vector B, you could have also found it out. I will write that down for you. Okay, so in that case, if you wanted to find out it against vector B, in that case, let's call this angle to be, let's give it a name. Okay, let's call this angle to be, let's say I have this angle, which is, let's say this is beta. Okay, let's say this is beta. So beta will be equal to tan inverse a sine alpha divided by divided by b plus a cos alpha. That's how simple it is. So that's all from this video. I hope this helped you in understanding the parallelogram law of vector addition. And in my other video, I have discussed about head-tail method. that is also used, head turn method is also used to add vectors. I hope you watched that video and subscribe to my channel for more videos like that.